that maintains that modern warming is due to solar radiation, and that we're now at the highest level of solar radiation for many years. But the problem is when you compare solar radiation, I'll do the climate change talk, the changes in solar radiation and the changes in the effects of carbon dioxide, it makes sense to go for carbon dioxide and clean up our act. But anyway, field work. This is travel, and in the old days, we used to use dogs. And this, incidentally, is not a glacier, right? It's sea ice. And you can tell it's young sea ice because all these features on it are pretty sharp. Now, when I say young sea ice, it's not first year sea ice. It's sea ice that's been around for maybe 1 or 2 years on the Arctic Ocean. But that's the way we used to travel. Now we use a snowmobile, and that actually is my daughter on there driving. And this is one of the glaciers further north than us on Devon Ice Cap. These are poles that are drilling, and the rest of that stuff is tents and scientific equipment and living gear, shall we say, because once we get landed, we travel around on the snowmobile, put up a tent at the end of the day, cook, and that's the way we kind of go on. When we were in the Mount Logan area, we pulled our gear up. Can't recommend it, frankly. It's just too much like hard work. And you have skis, and you put skins on the skis. Some of you may have done backcountry skiing, and this is one of our Japanese colleagues. We find that as far as research is concerned, if we have a big project, we have to cooperate with, say, Americans or Japanese or British, because we couldn't afford to do some of it on our own. And you do find crevasses. This is why you take someone else with you and you make them drive the skidoo and you go behind on skis or sat on the sled. And we don't, when I first went up there, we didn't have GPS, and this is one of my colleagues in the winter getting some star shots. We were in the winter and we were actually camped on, well, we were on that float for, what would it be, about 4 or 5 months. And on the Arctic Ocean the ice moves and it was carrying us in the way we wanted to go, but you didn't have a GPS. We get taken in with twin otters to the starting point, and may I say, I know it's an international group here, but I certainly think that Canadian bush pilots are among the best in the world, and they often take these things down to the Antarctic where they're contracted by the Americans to do all the, what shall we say, they can land on all sorts of rough terrain. And I think it was one of these that even went to the South Pole in winter to pick up someone who was sick at the South Pole. And we also use helicopters. Again, you need an assistant. You might not understand why. This guy's is a net. You put all your stuff in the net except yourself, and then it goes up with the net slung below it and takes all the gear to your campsite. But when you connect up, because of static electricity, you can get a real big shock. So I've never hooked up anything for obvious reasons. Let someone else do it. These, incidentally, are Russian helicopters. We worked over in Russia a few years back, and these guys are first-rate pilots, but I know there's some Russians here, but I have to tell you this. The Russians are really, really different to us. And I used to, when I used to fly into Russia to do this work, I'd think, what the hell am I coming back here for? What do I want to go to Russia for? And then when I left, I was always disappointed to leave. But these pilots were first-rate pilots, but we're always talking safety regulations to the point of absurdity. And one of our pilots this year said to me, He said, if they keep putting safety regulations on our aircraft, twin otters, he said, we'll be too heavy to take off. Not these guys. I remember inside one of their helicopters that one of the guys was sat on the fuel tank smoking a cigarette. I'll tell you, they were damn good pilots. One of these guys, as you know, Russians can also handle their drink. They get a lot of practice, I guess. And this particular occasion, we had a Norwegian guy with us. He worked with me for years and years. He was a magnificent looking guy with a big beard, and they thought he was marvelous. So they said, okay, come and have a drink with us. But they didn't drink vodka, they drank neat alcohol. And he got horribly drunk. And fortunately, when he was going to his room, it was a very narrow corridor, so he could bounce from side to side on his way. But the guys who flew these things said, okay, we were so impressed with his alcohol capability, we'll take you for a free ride tomorrow. And they took us, I can't remember the island, it's off the north coast of Siberia. And some of the things they were doing in those helicopters, there was a thing called a hoodoo. I don't know what they are. They're like tall pillars of sandstone, I think they are. And these guys would just go round and round the things, facing it all the way. And I'd be looking through the window to see that the rotors weren't going to hit the bloody things. But they were really good. In the Antarctic, we used to, some of you may have already seen in your previous trips, Port Lockroy. We used to live in huts, surrounded by penguins, by the way. Now, we might put up a tent. They're quite easy to construct. They're very, very comfortable. There's our international crowd with some of our Japanese colleagues. And that's inside another hut. But sometimes these damn things get buried. This is the hut down here. And you have to dig your way down and get in. And then when you get in, you find it's festooned with ice crystals. You turn the stove on. You make sure the chimney's on completely, by the way. You turn the stove on and then you get out because it rains, all this stuff. It hits the floor and freezes. But as I say, generally we use these tents like this. And they're very comfortable. They're almost the same as Scott used to go to the pole. They're double layered, ventilator up there. This thing's a weather station. We have a lot of those. And you can get them to record almost whatever you want. Anyway, this is another camp, Mount Logan, and another one, small tents in that particular case. And this is an automatic weather station that we use, solar panel, which provides the energy for the thing to go. This is what this does, it measures the distance to the snow ultrasonically, so it tells you whether the snow is accumulating or melting. Temperatures come along in there, and I find them now absolutely essential. I won't go into the details. It's to do with warming, and I couldn't work without the things in certain parts of the ice cap, but they don't always tell you the truth. They get covered with this stuff. And you come back in and you find it's been calm all the winter because the anemometer propeller here has been completely blocked with, these are what is called rime, cloud deposits. And if you're in fog and it's a bit windy, it just builds up very, very fast, very, very quickly. And that's just another, this is Logan when we had to hike up to the campsite. So I go into the various types of glaciers, and we may get a chance. There's two places where we may get a chance. I don't think we're going to go on one. We'll certainly see them. And valley glaciers, you probably all know, that's the kind of area of the talk. I've worked on this one since 1961. And needless to say, it's, I don't see too many differences from year to year. And this is why it's essential that we measure these things every year, because the changes from year to year may not be that great, but if you add them up, they're losing mass all the time. In other words, the volume's decreasing. That's another valley glacier and another one. And then what I'd work on are ice caps. And this is very much, seen one ice cap, you've seen them all. And like that. And there's the tent. You have to cover your snowmobile in case you get a blizzard. And this, in fact, maybe my next talk will go into, is what's called a split horizon. And it's due to an inversion and refraction of light. Ice streams, mainly in the Antarctic, they move very quickly and they're massive, and they disgorge enormous amounts of ice into the sea. And there are some, there's one or two in Greenland, but most of these things are in the Antarctic. They're enormous. And it's been found when the bed of this thing is a mixture of water and you could call it mud. So it's well lubricated. And this is very important in terms of this lubrication in terms of climate change, and I'll get back to it later. Let's say you don't go over these with a snowmobile. This is junction between an ice stream and a slower moving ice. These things can move kilometers in a year. Normally a valley glacier like the one I work on, 30 meters a year, that's all. And then there's ice shelves, and what the hell's going on here? Can you just go back a few? There you go. Okay. Thanks. There are ice shelves in the Arctic, and they're up along the very northern coasts of Canada and Greenland. And you may have heard of one that a huge chunk of one went out last year, the Ailes ice shelf. The BBC were over this last spring filming what was left of the ice shelf, and when they break off, they go around. I calculated that they go round for up to, say, 30 years until they get into another current and they come out over here. And this is one of them. It's just about, let's say they're a couple of 100 meters thick of that order, but it's sea underneath them. They float. And they're fed partly from the valley glaciers, but it's partly the snowfall on top of them that builds them up. And then we go to the Antarctic. These are the three places I've worked for future reference. East Antarctica, that's about the coldest place in the world. The average temperature here is minus 60 Celsius, average temperature. South Pole, which is warmer than that, but still bloody cold. And then West Antarctica. And while I've got this up, you're going to see Al Gore's movie on climate change. And there's a book here that I deposited here on climate change by Al Gore. And for some peculiar reason, there's one or two massive mistakes in it. And one of them is that he calls this an ice shelf, which is ocean-based, and it's not. This is an ice shelf. All these massive things are ice shelves, and they have water underneath them. And they're well over 100 meters thick. And you can tell from this is a piece of an ice shelf. You can just think of it, there's nine, this is only 1/9 above the water, the rest is underneath the water. This is a kind of an ice shelf, very level features, and you can see the the different layers of snow. This gives you the clue of why ice cores are so valuable, is that as the snow falls, it doesn't go away, and it traps all sorts of things with it that give you a clue to what was in the air when the snow fell. So how does it form? This is in the Antarctic, and sometimes up far north. This is the main form of precipitation. That's an ice that falls like this. If you look at it through a microscope, the snow looks just like these things. They're called ice needles. They're also called diamond dust. They're the things that cause halos around the sun. What happens is that these things fall onto the surface, Then they start to change and compact, get denser, right? Until they form, eventually, solid ice. That's back at the surface again. It's a pit we've dug with just a straightforward shovel, and each one of these red dots marks the top of a year. That'd take me a long time to tell you, but there's several ways. It's a damn good question. And if you get snowfall in the winter, they're that kind of snow that I just showed you. If you get snowfall in the summer, it's the stuff you experience further south. Big, dendritic snowflakes. And so one of them compacts so that it's dark. The other one doesn't compact quite as much, the summer one, so it's lighter. What the problem here is that it does melt somewhat, and that mixes it up a bit. And then you can use chemistry. And the chemistry, dirty spring, clean summer, dirty spring, clean summer. And you can go down and you can count the layers. In Greenland, they can actually see the annual layers back 40,000 years. Eventually the bubbles become separate, but each one of these bubbles has the atmosphere in it when it fell as snow. And you can look at you can take all those bubbles. There's a special way of getting the gas out of the bubbles, and you can tell what the atmosphere was built up of, how much carbon dioxide there was, and so on. And anybody can do this if you got the right stuff. This is a thin piece of ice. If you get a thin piece of ice and you've got a pair of Polaroid sunglasses and you get someone else's Polaroid sunglasses, if you turn the Polaroid, then it goes black. You can't see, and you put a thin piece of ice in between. This is what you see. Each one of those is a crystal. And this is a centimeter grid, and this ice is from the last ice age. It's still in the ice caps in Canada. It shows you, and that, so you're going back, say, 20,000 years with that stuff. And you see these little light bands, and that is where it's been melting. And by seeing how many of these are in each annual layer, you can tell whether the summer was warm or cold. And here's another example. All these light, there's no bubbles there, and that's because the meltwater percolated down, spread out, and refroze. So you go down the core, and you look at how many of these ice layers there are in a particular section, and it tells you if it was a warm summer or if it was a cold summer. So if you have any questions, that's the field work we do, and that's how glaciers trap the atmosphere in them. And in a later lecture I'll explain what kind of evidence we've had from them, because I think the first time that people were convinced that carbon dioxide, well, the physicists knew that carbon dioxide warmed the atmosphere. Okay, the models may not be precise, but it's the kind of stuff that you people learn at school, that carbon dioxide keeps the planet warm. So it makes damn good sense that if you put more carbon dioxide into the air, it'll get warmer. But the people who say it ain't carbon dioxide, it's the sun, they've looked at the last several million years of climate in rocks and all the various ways you can look at it, and they say it's the way the sun gets brighter and so on, sunspot activity. And I won't go into the details, it's not as simple as that. They've come up with a very good scientific theory of how that signal is amplified. Because if you just change the amount of sun that's coming into the Earth's atmosphere, it's not the rather subtle changes, but you have to amplify it, and that's what these scientists have come up with a very good amplifying argument. But the problem is, on a short time scale, sure, it's still the effect of the sun, and there is a warming effect of the sun right now, and it's only when I'll show you the diagram in another second lecture. It's only when you combine the solar radiation changes with the carbon dioxide changes that you get a very good fit with the temperature changes going on. But the strongest effect really does seem to be carbon dioxide. So although you might say, oh, it's the sun, it's playing a part, but only a small part. And yeah, I think I'll leave it there for now. You may have some questions. Shout them out. Somebody said, are you entering second childhood? I've never left the first, frankly. But one of the advantages of getting older is that you forget things. And so you can read a book. You only need one book. You read the book, by the time you get to the end, oh shit, what happened at the beginning? So you start again. I'm not sure at what stage you don't remember the page before. I'm not looking forward to that stage. Question?
I had a question. I just wondering what exactly, I guess,
Louder.
classification-
Can you stand up and say it loud?
I was just wondering exactly what the criteria were to tell the difference between like an ice cap and sheet ice and stuff like that. You didn't really go into that.
No, okay. Okay, so the question is, what are the criteria you use to differentiate between the ice caps? Most of them are pretty obvious, right? You know, you see a valley glacier, it's in a valley, right? It's got steep walls either side, but its length is much, much greater than its width. Then you go into an ice cap. An ice cap, it's pretty crummy criteria in a way. You could say it's smaller than an ice sheet. An ice sheet covers vast areas. An ice cap tends to be in one area, comes up at the side and up to the top, fairly symmetrical. But an ice sheet, it all shapes and all the rest of it. There's these ice streams in it and all that. There's only two big ice sheets. There's only, I guess you could call the Greenland. I don't think I'd even call that an ice sheet.
What about an ice shelf?
An ice shelf, well, those are the ones that float. They're floating, right? And the reason they're there is that as they move out, they move onto islands and over the islands, and they actually act like pinion points. And they'll break back every now and again. They break, otherwise they'd cover the face of the earth in several thousand years. So they keep on breaking off. And the question with ice shelves is, you know, one of the things you have to be careful with climate change is don't put everything down to the climate change, or global warming as it's rather simplistically called. You know, a lot of people say, oh God, it's what a hellish warm summer. Global warming. May be right. But then you get a cold summer the next year and all the doubting Thomases say, yeah, so where's your global warming? This kind of stuff. So you really have to be careful with the things that you assign to the warming. Any other questions? Okay. Oh yeah. Sorry. Go ahead, Mike.
When you say you're taking ice core, what exactly do you mean by that?
Yeah, I should have had that on there. You take it's like a barrel with teeth on the end, right? And you can do a shallow core. You can do a shallow core, maybe 20 meters. And then you have these metal extensions to put the barrel deeper, 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 and bring the sample up each time. But when you do a deep core, it's the barrel, teeth on the end, and the cable that comes up has got electric conductors inside, and it goes up to the surface where the power is. And that goes on cutting ice, and then you have to bring it up every 2 meters. Empty out the ice core and put it in a bag, take it back down south to study it.
So how was Al Gore wrong in calling that part of Antarctica an ice shelf?
No idea. No, I really don't know. He's also wrong in another thing. There's an article there on Kilimanjaro. That's the, you know, it's kind of an ice cap on top of a mountain, and it's near the tropics, and that's getting smaller and smaller and smaller. And it's often used as an example of global warming, but it isn't. There's a paper being published recently, and that is due to various things like changing cloudiness in that area, and it's due to solar radiation not getting to the ice as it did in the past. But Al Gore can be forgiven for that one because that's only been found out recently. they have upper air temperatures there. There's no change in that. It's like somebody mentioned a while, why are some parts cooling? Where I work, if you looked at a map of the next lecture, I'll show it. You look at a map, and usually you show red where it's warmed up a lot, and blue where it's cool. And there's a part of that that's cool. But that's on an annual, this is why it's complicated, that's on an annual basis. And the summers in that area have actually warmed. The winters have got slightly colder, but the summers have gotten warmer. And so you really have to look down at the seasonal details of it. Anyone else? The back there?
Do you split the ice core too? Or
Sorry?
the ice core? Do you split it? Like with a saw and
I'm
sample
not
them?
quite sure I understand what.
The ice core.
When you get an ice
Oh,
core
okay,
up, you
okay.
split it.
If you're, for example, the Greenland ice core, they're very important. They're very expensive to drill, so you get a lot of international organizations working on them. So they have to be sure that none of that ice is wasted, and so they cut it up in a very, very careful fashion. And the Swiss, they're absolutely marvelous at making miniature things and all this. They worked with us once, and they've got a device. They get the core, and I'm not sure if it's before it's split or not, but they run like it looks a bit like a soldering iron. They run this in, it melts the ice, sucks the water up, and this damn stuff goes off to all these different instruments while you're in the field, and they can measure all sorts of different things as they go down the thing. But it has to be cut up very, very carefully.
What about the issue of sea level, rising sea level? The threat, as I understand, is from melting Greenland ice and melting Antarctic ice,
Rising sea level.
My question is that already happening and already documented because of the more southerly glaciers that are melting?
Yeah, the question is, sea level rise, glaciers melting, is that already being documented? It's a good question. The answer is yes. I mean, the stuff that I've done with colleagues for 40 years in the Canadian Arctic, I can't remember the exact numbers, but the ice caps in the Canadian Arctic are losing, doesn't sound much, they're losing approximately, if you spread the loss all over the ice cap, they're losing about 10 centimeters thickness a year. Now that's going to take a long time for them to go completely, but they are losing mass. Now Greenland, one of the big IPY projects is a result of what they've just found. If you get more meltwater, it goes to the bed of a glacier, it's like oiling the bed, and it will double its speed overnight. So you get more icebergs like you're going to see. So yes, one of the problems though is Antarctica. It's such a vast continent. It's so difficult to work there that it's still kind of a big unknown. But one of the things that really took me by surprise, I get the New Scientist every week. It's easy reading and it's got all different types of science. And they had two articles in the New Scientist, completely unrelated. You would think they weren't supposed to be related, but they were. And one of them was the amount of ice coming from Greenland into the sea every year. You could interpret that. It's going to raise sea level. The ice, you could regard it as water. It's going into it and it's raising sea level. But then there was an article on agriculture in India, part of India, where they're sucking water out of the ground table, the water table, groundwater table, and they came up with some numbers. They're sucking this stuff up, you irrigate the land, it evaporates, goes back in the sea, but it's not replaced at the same rate they're taking it. And I looked at the numbers, and there was as much water going out of the groundwater table in India into the sea as there was ice coming from Greenland. And that's another big unknown. I mean, I've been down to Arizona and you see people they're watering their green grass and all the rest of it. They're sucking the water out of the ground, and that stuff goes back in the sea and isn't replaced at the same rate as it's being taken. So it quite astonished me that sea level rise is not just due to glaciers. It's due partly to the expansion of seawater, but it's also because human beings are taking more water out of the area they're in than is coming back as precipitation. Yes.
I live north of Toronto on the Oak Ridges Moraine, and recently they're building sewers in a town 10 minutes from my house. And a lot of people were protesting against it, and also especially because they use King City water, and so the water is coming from an aquifer that's where we are. And then now that there's lots of sewers, we're going to be sending all of this good fresh water away, and like we're not, because it's not being processed where we are, and so instead of going to septic systems, it goes back into the system. It's going to be sent away to like the Great Lakes and stuff.
Well, yeah, that's another example. The Oak Ridge Moraine, some of our guys are working on that very problem. Again, you're kind of using massive amounts of water which aren't necessarily replaced. Water is one of the big problems for the future. You get cases, I know this isn't glaciers, but it is certainly, and it's not just climate change. Believe you me, the problems on the planet aren't just climate change. You look at the Middle East, and I remember reading that they're sucking so much water out of the ground in parts of the Middle East, the water table's gone down so deep it's been replaced by the sea. It actually, the sea's coming back, so they're putting salt water into the ground, and water is an enormous problem. It ain't just due to glaciers. Peter.
Fritz, one of the CDs that's on that list of CDs that I've got available if people want to look at it is the assessment of the water on a global scale, water resources. And that's got some really quite dire predictions in it. So it's got all of that sort of information. So it's there if anybody wants to.
Yeah, Peter's saying that that one of the CDs he brought tackles this kind of problem. If you wanted to borrow it and look at it, go to Peter. Anyone else? At the back.
We often hear about the enormous reserves of hydrocarbons in the continental ice shelves. So how do you account for this fact? And does it mean that in some areas the ice is richer than in the others, for example in the Arctic and Antarctica?
Say that again. The hydrocarbons where on the ice?
Right, in the continental ice shelf. So there are...
Wait a minute, continental ice?
Right, in the continental areas, in the shelf areas of the ice. Do you know what I mean?
No, I'm just not sure if you mean ice shelves or the actual continental shelf under the sea.
Continental shelf, that's what I mean.
Under the sea.
Under the sea, right.
Yeah.
So how do you account for this fact? I mean, how is it actually happening that there are enormous reserves of hydrocarbons in the ice, especially in the continent?
Hey Peter, answer it. I'm not sure. I'm not sure.
What the reserves are, they're in the sediments off the margins of the continent. And in some areas it's frozen, but it's basically crystalline form of methane. So that's where that's what these resources are. They're known as gas hydrates, and they're extensive both around the circumarctic region. There's lots of them in off the Beaufort Sea, and there's lots of them off the coast of Russia. But they're also present in all sorts of other places. And it's estimated that in terms of the amount of energy available in those hydrates, if we could ever tap them, that there is more energy in that source than all the energy in any other source still in the ground or that we have used in the past.
Right.
The problem is, say?
How did they get in there?
What's the problem?
Yeah, they form under pressure from the carbon and so on in the sediments as they're deposited. In the north, in the Arctic, they're frozen. But it's a rather neat crystalline structure. And I heard, who was the person that there's one real expert in Canada on this, and he had a model of just a cube which is about 10 centimetres each side, and that stored enough energy in methane to run one house for a year. There's a vast amount of this stuff. One of the real problems with climate change on this is that as permafrost conditions in the Arctic change, this may well be released naturally to the atmosphere. And that may be a far greater problem than carbon dioxide. It doesn't stay in the atmosphere as long as CO2, but it does have a major impact on climate.
And it's a more active greenhouse gas.
Yeah.
In fact, nowadays, all of these gases, including water vapor, are measured in terms of carbon dioxide units. And that is, whatever their power is in absorbing radiation, you multiply that by the period of time it's in the atmosphere. And as Peter said, methane is much more powerful greenhouse gas than carbon dioxide, but it doesn't stay in the atmosphere as long. And as far as this, you were asking how the hydrocarbons get into it, and your explanation, Peter, air in the ice is the same. When you drill very, very deep, like they do in Greenland and also Antarctica, it comes up completely clear with no air bubbles at all. And if they started to work on it, it'd just explode and just go all over the place. So they very carefully put it aside and leave it for several days, and the bubbles, because the pressure's gone now, right, come up at, the bubbles come back in again. It's a similar kind of process. Anyone else? Okay, well, thanks for, nobody left, so you didn't learn anything.
Ordinary liver, so I guess I won't like that liver. But what do you taste? The blubber that we taste, or the muscle?
The different parts. I like
helicopter!
The best anatomy class. These guys are masters. I can just imagine myself being so I'm gonna say that. Huh? I'm ready.
That's your
Bring it
part.
on.
No, he's prepared off to try to.
Kau tu kain telawat si mama kaluang mga. Cakap siat tahu na.
Oh, yeah.
Mga kumat. Bahay lunay.
What was that for? Blubber. Yeah. Oh, yes. Kuyamik. Abu, Jeff? Yum.
Yeah, right.
Yes. Kuyamik. It's really good.
It actually is. I had that piece last year. I can't explain it. It doesn't taste like anything else. Mary, can you ask him if I can have a piece of the liver?
Irvin, you're in there, buddy.
What did he say? Say, oh.
Yeah?
That's the dog's name.
Not Ralphie.
Thank you.
Whoops. About to lose my glasses.
Good. Cakap siat tahu. Cakap lang apa siat?
Oh yeah, I had it last year.
Cakap siat tak? Punah. Come no.
What does it taste like?
Saya kasi akan telangan itu sih. Ani tahu tu dengan lupa.
Okay, so the Inuit spare ribs.
Inuit. Ubang nak cewek makwa.
This is the women's pile. This is what women eat.
Betul upah. Upah.
I tried.
The women eat. Yeah. There's no rest.
There's no rush. Whenever I'm off, there's whenever I'm off. The thing is still inside. Because the head's still inside.
Careful.
Chris, Joyce, Jeff got it.
Yeah.
I want to try a piece.
Ask Mary to tell him to
Don't know which piece I want.
I've only had the liver, but the liver's good.
How much it taste like?
Mary?
Yeah, get two.
Tell me I want to try some liver.
Those who want liver. You want
Us too.
Let's go. Let's go eat.
Yeah, don't get in front of me.
Hey. Ako.
Liver.
Inung menulian nila ko din. Yung sukat na lang.
Said you have to marry an Inuk. Unalo. Tingusto ko may medyo. Okay, he'll give you some.
I'll have some too, I guess. The smallest piece. Oh, may I have some too, please?
Okay.
Oh, my bad.
Okay, cheers.
Yeah, I'm not in the...
Okay, it's okay. It's lean.
Yeah, it's good. Tastes like fish.
Which one? The meat?
Different parts taste different. Thank you.
Yep, meat. Yeah. Daniel, which one?
Did you taste the meat? Is it good?
Yeah.
Yeah?
I tried liver and meat.
Which one? Meat?
Good.
Well, I guess I gotta try it.
You don't have to.
You should.
It's not. It's actually not bad tasting, but
No?
it's a good experience.
Just what? Is it rubbery? Do you have to chew a lot?
It's quite normal.
Do you like sushi?
Huh?
Do you like sushi?
No. Well, yeah, I tried once.
You like sushi?
I'm gonna email you. I'm gonna write a
Okay.
letter to you. And say every time there's fear, I would write to you and say we think of you.
Okay.
Oh, anyone?
Yes.
Okay, then I'm gonna go get washed up now.
Try a little piece of meat.
A meat?
Yeah.
Okay.
Show my students. Bon, bon, on va essayer ça, là, de la viande de phoque crue, pour voir si c'est très très bon.
Kuyo,
Hey.
ukto na nga siya magkawit ang kailong nagalala doon. Walang makawit.
I just film myself. I will try another piece. You? Okay. I'll be filming you too if you want.
Okay, ladies, you want to
Whoop.
try?
Next event is Alaskan Hunter. And the world record for this is 7 feet 7 inches. You must have this palm straight down to the floor and use his other hand to hold the other foot and kick the carpet with the opposite foot. And he must maintain his balance as well.
Don't touch.
Hey,
Don't touch. This one.
they're coming here. They're coming here. Don't touch me. There's the bathroom. Don't touch me. Why? No.
I have to stop.
You must keep your knuckles together.
I'm sorry. No, don't touch. Don't touch.
That's his.
Ah, elle vient de revenir en vie, là.
I smell cookies. Cookies.
Ah. Il est 6h25, nous sommes le 8 août. C'était une journée assez particulière pour moi. J'avais pas pris de médicaments contre le mal de mer et durant la nuit, disons que ça a commencé à brasser pas mal. En plus, il faisait très chaud dans la cabine. Le pont numéro 3, où sont les garçons et moi-même, il y a beaucoup trop de chauffage. J'ai dû fermer toutes les trappes, même si pourtant c'était froid à l'extérieur. Alors, j'arrivais pas à dormir à cause de la chaleur, mais là, j'ai commencé à avoir le mal de mer. Donc, le temps que les médicaments prennent effet, je n'allais pas pouvoir dormir tout de suite. Donc, je me suis levé et je suis allé sur la passerelle Capitaine. Et là, j'ai pu voir mon premier iceberg. J'étais le premier à en avoir un gros, justement parce que j'étais le seul qui était debout. J'ai pris une petite séquence pour vous montrer comment que ça brassait. C'était pas énorme, mais disons pour quelqu'un qui fait dans le mer, c'était suffisant pour avoir un certain malaise. Là, les médicaments ont été faits après. Je me suis senti beaucoup mieux, surtout après le déjeuner. Parce qu'il faut manger régulièrement. Si on a le ventre vide, c'est pas très très bon. Alors aujourd'hui, en après-midi, on est allé visiter le village inuit, complètement au fond de cette baie bien protégée. Et le village s'appelle Kimuruk. Alors là, on a eu droit à des visites guidées du village. On a visité aussi un beau petit magasin avec plein de belles statuettes inuites dont les prix étaient parfois assez exorbitants, mais paraît-il que c'est encore moins dispendieux directement là qu'à Montréal, bien sûr. À Montréal, ça serait le double du prix. Alors, j'ai rapporté, excusez-moi. Alors, j'ai rapporté des petits Inukchuk. 3 petits pour mes enfants et 2 plus gros pour décorer dans la maison. Certains ont acheté des statuettes de morse, de baleines. Ça a été très populaire. Mais ce qui a été le plus populaire, c'est lorsque l'aîné du village a procédé à la dissection du phoque. Vous pouvez voir sur le site. Par la suite, j'ai fait faire une traduction à cet aîné par Mme Mary Simon, avec qui je suis devenu très amical. On jase souvent des Inuits, elle m'a appris beaucoup de choses. Il lui a demandé s'il aurait des ossements à vendre. Que j'étais professeur, je voulais des ossements. Alors, j'allais faire un petit tour de 4 roues, il ne parle pas un mot anglais, presque. Il a fallu négocier un peu et j'ai obtenu un petit panache de caribou et un crâne de morse. Sans les défenses, bien sûr, parce que les défenses sont en ivoire et les Inuits les utilisent pour faire des petites sculptures, ça a une très grande valeur. Mais même sans les défenses, c'est assez intéressant de voir les différentes facettes de ce crâne. Les enfants étaient très chaleureux, ils étaient après nous autres, ils voulaient tout voir, ils voulaient voir nos caméras, ils voulaient voir tous les gadgets qu'on avait apportés. Et dans le gymnase de l'école de Kimuruk, on a eu droit à des démonstrations assez spectaculaires de prouesses d'habilité inuit, à laquelle les étudiants du bateau ont bien voulu participer. On a même eu droit à quelques extras de la part d'un étudiant russe et d'une étudiante chinoise. Roman, l'étudiant russe, et Sonny, notre étudiante chinoise. Son professeur accompagnateur, je suis certain qu'il aurait gagné, mais il n'a pas voulu participer. Il était dans l'armée chinoise, il fait du kung-fu. Je l'ai vu, les bras très très modeste, très très discret. Bon, il est supposé donner des cours de tai chi sur le bateau, peut-être plus tard cette semaine. Alors c'est très tranquille, le bateau est à l'arrêt, on ne bouge pas, c'est une vraie mer d'huile, pas de vent, beaucoup de moustiques. Moscol aux 10 minutes. J'ai jamais vu autant de moustiques de ma vie. C'est absolument phénoménal. Pas de chasse moustique ici, c'est presque un suicide. On se fait dévorer tout cru. Les étudiants. Je vais partager ma bouteille. Et Moscol, ça n'en prend pas beaucoup. On a eu assez, juste un petit peu comme ça, et c'était assez pour les 8 personnes du Zodiac. Ils ont été bien protégés après ça. Alors, les Zodiacs commencent à revenir. Lorsque tout le monde va être rentré sur le bateau, on va lever l'ancre et on va partir pour notre prochaine destination, dont je vais vous parler demain. Mais, hélas, je n'ai pas le même budget que certains professeurs universitaires, disons que ça n'aurait pas été évident de ramener ça à la maison dans mon sac de voyage. De raison, il y en a qui voient grand. Alors, combien pensez-vous qu'il a payé pour ce splendide spécimen de vertèbre de baleine? Si vous avez pensé 100 $, vous auriez eu la bonne réponse. Pour des immenses panaches de caribou, plus gros que le mien. Le mien, c'est un petit panache d'une femelle. Girl caribou. Comme a dit l'aîné du village, lui a acheté des panaches de mort. C'est assez encombrant, merci. Je ne vois pas comment est-ce que j'aurais pu ramener ça dans mes bagages en autobus. Alors,
Yoo-hoo. Say hello.
Ты знаешь, я был там, наверное, в зауде, даже так. Да, прохладно. Да, Борис, да нет. Молодец, не падай. plastic. Я закрываю. Маленький. Рад. Что сколько? Ты знал? Горячий. Я спугнул своего махровым полотенцем. Deflating, to say the least. My wife would close the door.
Ah, well, you are already married then. You didn't need a present.
Oh yeah. my God, I was looking at their So I hope we don't have that on there because I was just like made it up at him. Here you can videotape.
I also love it too when they're looking at you and you're trying to hide that.
Oh yeah, we are going
Jeff, hi. For dinner tonight, the seating plan is first letter of the first name.
First letter of the first name?
Hey, did they throw away my numbers?
I hope not.
I hope not.
Because that was a real variety.
Huh?
And the Jays win. They have 3 tables. That Jay.
Yeah, fabulous. I know, I'm a I want to go there. Yeah, try going now. Oh man, he'll just give us a look like get the heck out.
Ah, shoot. There was water on the lens. Whoops. I got 3 minutes of tape left. At least, I'll show at least the buoys.
They're not waving back.